In this video, we are going to discuss about converting ER diagram to tables, or this can also be called as reduction of ER diagram to table. So some ER diagram will be given. So here our target is we have to convert that ER diagram to tables. So for this totally we have to follow 5 rules. Rule 1 is for converting strong entity set into tables. So how to convert a strong entity set into table. Rule 2 is converting weak entity set into table. Rule 3 is converting a relationship into tables. Rule 4 is for binary relationship with cardinality ratio. If a binary relationship has cardinality ratio like 1 to 1, 1 to many, many to 1, many to many mappings, then how we are going to translate that relationship into table. And the last one is for binary relationship with cardinality ratio and participation constraints. So by following these 5 rules, we can convert any ER diagram into tables. Let us see the first rule. For converting strong entity set into the table, we know what is strong entity set. If an entity uses primary key, if an entity uses key field, then it is called as strong entity set. Let us see this example. Here we have student entity, and these are the attributes of the student entity. Roll number, name, address. Address has door number, street, city, date of birth, age and mobile. Let us see how to convert this strong entity set, this strong entity into table. Let us see the first rule. Entity becomes the table name. Here what is the name of the entity? Student. So student will becomes the table name. Student will become the relationship name. Let us see the second property. Single valued attributes or simple attributes becomes column names of the table. We know what is single valued attribute. If an attribute has only one value, then it is called as single valued attribute. Aadhaar number, a person can have only one Aadhaar number. PAN number, a person can have only one PAN number. So they are nothing but single valued attributes or simple attributes. So simple attribute means that attribute cannot be divided further. So that is atomic. If you take this roll number, we can't divide roll number into further. Okay. If you take this name, we can't divide that name into further. Okay. If you take date of birth, we can't divide that date of birth into further. Okay. So they are nothing but simple attributes. So they will simply becomes the columns. So if we take this diagram, rule number means this is some key field, name is a simple attribute, address is composite attribute, date of birth is simple attribute, age is derived attribute, mobile number is multi-valued attribute. So what are the simple attributes here? Here these will become the column names. So name is the simple attribute, so name will become the column name, and next date of birth is the simple attribute. So date of birth will become the column name. Okay. So these are the simple attributes. Now let us see the next one. Ignore derived attributes. We know what is derived attribute. Derived attributes are not stored in the table. Derived attributes are derived from other attributes. Here this dashed ellipse. Derived attributes are always represented with dashed ellipse. Age is derived from the date of birth. There is no need to consider this derived attribute. So no need to store age in the table. Okay. So ignore derived attributes. And the next one is simple attributes of the composite attributes are to be considered, but ignore composite attribute. What is composite attribute? Composite attribute is made up of several simple attributes. If we want, we can make this name as the composite attribute also. But this name will become the composite attribute if it has attributes like first name, last name, middle name. But here we don't have such scenario here. If you consider address, address is composite attribute. Why? Because address is made up of 3 simple attributes. Here there is no need to store this address in the table. but we have to store simple attributes of this composite attribute in the table. So what are the simple attributes of the address? Door number, next street, next city. So let us store them in the table. So there is no need to store this address in the table. Why? Because this address is composite attribute. Now let us see the next condition. Multi-valued attributes are represented by separate table. So if we have multi-valued attribute, then we have to make use of another table. We have to create another table. Here, what is the multi-valued attribute? Mobile number is the multi-valued attribute. Why? Because multi-valued attribute means if you take mobile number, a person can have multiple values. So multiple values are stored in the table. But here we have to store, in a column we have to store only one value. So that's why we need to create one more table. Let name of the table is student underscore mobile. Student underscore mobile. And the fields or the columns of this one are the primary key as well as mobile number. In this diagram, roll number is the primary key. So this roll number now will become the foreign key. This roll number will become foreign key of this student underscore mobile table, and we have to store mobile here. So whenever there is a multi-valued attribute, now we need to create another table with the fields. We have to take the primary key. That primary key will become the foreign key of this table as well as that mobile number. Okay. So this is about multi-valued attribute, and the last one is key attribute. Key attribute becomes primary key of the table. Key attribute will become primary key of the table. So here what is the key attribute? Roll number is the key attribute. Now this roll number will become the primary key of the table. So in this way we can convert strong entity set into the table. Now let us see the rule 2. For converting weak entity set into table, we know what is weak entity set. Weak entity set doesn't have any primary key, but it uses partial key. In this example, we have employee entity. Employee has some key field. So employee will become the strong entity. Here dependent is enclosed within two rectangles. So dependent will become the weak entity. Here the relationship between employee and dependent is policy. So employee has some policy. So dependent depends upon the policy. So dependent means employee wife or employee children's. Okay. Here the attributes of strong entity are employee ID, which is some primary key, employee name, salary. Here this is policy. This policy is relationship. In order to show the association between this relation and weak entity, we always use two lines, or we can use in place of two lines, we can use a solid line. We can use a solid line and the arrow will be towards the relation. Okay. Here this is weak entity. So that's why weak entity relationship is always represented by double diamond symbol or double rhombus symbol. Okay. Here the participation is 100%. Why? Because dependent always depends upon the employee. So here the participation is total participation. Total participation is 100%. So how we are going to convert this weak entity set into the table? So already we have seen about strong entity set. So we need one table, that is employee table. Employee table. The first field is employee ID, that is key field. So in table also employee ID will become the primary key. Next, these are some simple attributes. So store employee name and sal. So this is the first table, and the second table is combination of these two. We have to combine weak entity set with the relationship. So the second table name is dependent underscore, what is the name of the relation? Policy. Policy. Now dependent underscore policy contains the attributes of the dependent table. Here this is partial key. Partial key is always represented by some dashed line. Okay. So department name, this is partial key. Next we have one more attribute called relationship, as well as it includes employee ID. It contains employee ID. But in this table, employee ID will become foreign key of department underscore policy table. So in this way, we can convert weak entity set into table. Till now we have seen two rules. Rule 1 is converting strong entity set into table. Rule 2 is converting weak entity set into table. Now let us see rule 3. Rule 3 is converting a relationship set into the table. Here we have two strong entities. They are employee and department. The attributes of employee are employee ID, employee name, sal. Here employee ID is the primary key of this table. Here we have primary key. So employee entity will become the strong entity. Next we have department table, department entity. The attributes of department entity are department ID and department name. Department ID is the primary key. So department will become the strong entity. So here we have two strong entities. They are employee and department. Why? Because both these entities have some primary key. Next here the relationship is work-in. So work-in is relationship between employee and department. Employee works in department. Since is attribute of this works in relationship. This attribute is called as descriptive attribute. Okay. Now in order to convert this one into table, we require three tables. In order to convert this ER diagram into table, we require three tables. The first table is employee, the second table is department, the third table is works in. So the first table is employee, and the fields of employee are employee ID, which is primary key, employee name, next to salary. And the second table is department table, and the columns of department table are department ID, which is primary key, department name. And the next table is works in table. Works in table has here in employee table the primary key is employee ID. In department table, department primary key is department ID. Now those two keys will become the foreign key of the works in table. Okay. So here the column names are employee ID, which is foreign key, department ID, which is foreign key, and works in has an attribute called since. So these are the columns of the works in table. So in this way we can convert a relationship set into the table. Now let us see rule 4 for binary relationship with cardinality ratio. Here cardinality means here we have several types of mappings are there. Many to many, one to many, many to one, many to many, one to one. Already we have seen all those mappings in ER diagram video. Now let us see about these mappings. If the binary relationship has cardinality, then how we are going to convert that ER diagram into the table. Let us see that. First one is for binary relationship with cardinality ratio, many to many, represented by m is to n, many to many. So here we have two entity sets, A and B. Attributes of A are A1 and A2, where A1 is the primary key. Attributes of B are B1 and B2, where B1 is the primary key. For many to many, there is no arrow is needed. In order to translate this one into tables, here we require three tables. Name of the first table is A, name of the second table is B, and name of the third table is R. So for space constraints here, I am writing only schema. So the attributes of A are A1 and A2, where A1 is the primary key and A2 is the foreign key. The attributes of here, this is the table only. So here we have A table. A table has attributes A1, A2. A table has columns. We can call these as attributes or columns or fields. Likewise, B table has columns B1 and B2, where B1 is the primary key. Next B2. And this is the third table. The attributes of the third table are A1 and A2. Why? Because it shows the association between these two entities. So in entity A, what is the primary key? A1. In entity B, what is the primary key? B1. Now A1 and B1 will become the foreign key. A1 and B1 key is nothing but foreign key of this relation. So if we have many to many relationship, then we require 3 tables. Now let us see the second one. For binary relationship with cardinality ratio 1 to many. So 1 to many means 1 is to n. So same here also, same diagram like the previous one. But 1 means arrow will be towards the that 1. Here A is 1, whereas B means many. So 1 to many means one entity of this entity set A is mapped to many entities of this entity set B. So one entity of entity set A is mapped to many entities of entity set B. So that's why arrow will be towards 1 means arrow will be towards that entity only, that entity set only. Okay. So how many tables are required here? 1 to many. 1 to many means we require 2 tables. The first table is A. So many means we have to combine these two. Many means we have to combine the second entity as well as relationship. So the second one is, the second table is BR. So what are the attributes? What are the columns of A table? The columns of A table are A1 and A2, where A1 is the primary key. So 1 to many. So many means this B. So we have to combine B with R. So the attributes of BR are, so B1 is the primary key, B2, and here we are combining these two relationship with the B table. So that's why we have to consider, we have to include this A1 also. Now A1 will become the foreign key of this table. A1 will become foreign key of this table. So 2 tables are required. Now let us see the third scenario. The third scenario is many to 1. For binary relationship with cardinality ratio, many to 1, represented by n is to 1. Okay, let us observe this diagram. Same diagram, many to 1, many to 1. So many entities of entity set A are mapped to one entity of entity set B. So 1 means arrow will be towards that entity only. Arrow will be towards that entity set only. So how many tables are required here? Many to 1. So here we have many. In the left hand side we have many. So we have to combine A and R. So AR is the one table, B is the second table. The attributes of AR are A1 is the primary key, A2, and the next attribute is, here we are combining A with R. So we have to include B1 also. B1 will become the foreign key of this table. Whereas B means B columns only. So B1, B2. So here also 2 tables are required. Now let us see about for binary relationship with cardinality ratio 1 to 1 represented by 1 is to 1. So same diagram. So 1 to 1 means arrow will be towards entity set A and B only. So 1 to 1 means one entity of entity set A is mapped to one entity of entity set B. Here we can use 2 approaches. We can use 2 ways. The first way is we can combine A with R. So this is the first table. Second table is B. The second way is we can combine B with R. A is as it is. We can combine B with R. So we can follow one of these 2 ways. It is our choice. So AR means here we are combining A with R. A with R. So what are the keys? A1, A2. We are combining A with R. So we have to include B1 also. B1 will become foreign key. And what are the columns of B? Same. There is no difference. B1, B2. B1 is the primary key. And what is second approach? Way to A. A is as it is. So the columns are A1, A2. Whereas what is B? BR. So BR means we have to combine these 2. We have to combine these 2. So the attributes are B1. This is primary key. B2. B2. We are combining these 2. So we have to include A1 also. A1 will become the primary key. A1 will become the foreign key. So in this way, we can translate a binary relationship with cardinality ratio into the tables. Now let us see the last rule. For binary relationship with cardinality ratio and participation constraints. So here we have cardinality ratio as well as participation constraint also. Okay. Here we have 2 cases are there. Let us see case 1. Binary relationship with cardinality ratio and total participation from only one side. Second case is binary relationship with cardinality ratio, but total participation from both the sides. Let us see the first one. Same example like the previous one only. Here we have two entity sets A, B. A attributes are A1, A2. A1 is the primary key. B attributes are B1, B2. B1 is the primary key. Here the cardinality ratio is, arrow is towards A. So the cardinality ratio is, this is 1 to n, 1 to many relationship. And here we have, this is what? Total participation. Total participation is available from only one side. Okay. So already we have seen about what is 1 to many. 1 to many means one entity of A is mapped to many entities of this B. So we have to take two tables. The first table is A, and the attributes of A are A1 and A2. The column names of A are A1 and A2. 1 to many. So many means we have to combine these two. We have to combine B with R, and the attributes of BR are B1 is the primary key, B1 is the column, B2 is the second column, A1 is the foreign key. A1 is the foreign key of this table. Now let us see if participation is from both the sides. Here we are following 1-to-1 relationship. 1-to-1 relationship. Why? Because the arrow is towards A as well as towards B. 1-to-1 relationship. But here the total participation is from both the sides. Why? Because here we have two lines from this side as well as from this side. Already we have seen about 1-to-1 mapping. So simple approach. So just here, but here the problem is total participation is available in both the sides. If total participation is available from both the sides, then we have to combine everything. So the new table name is ARB, and the columns are A1, A2, B1, B2. A1 and B1 will become the foreign key of this table. Okay. Why? Because total participation is available from both the sides. Okay. So this is about how we can convert ER diagram into tables. Totally we have to follow 5 rules.